Next problem. Using properties, find z transform of x of n equals 2 to the power n sin pi by 2 n into u of minus n. Solution. Recall sin omega naught n into u of n has a z transform z into sin omega naught divided by z square minus 2z cos omega naught plus 1. ROC mod z greater than 1. Hence x1 of n is equal to sin of pi by 2 into n into u of n has a z transform. x1 of z is equal to sin pi by 2 is 1, cos pi by 2 is 0. So you get z by z square plus 1. ROC remains at mod z greater than 1. Okay. Now rewrite x of n as follows. Rewrite x of n as follows. X of n equals minus of 2 to the power n sin minus pi by 2 into n into u of minus n. Sin of minus theta is minus sin theta, therefore minus into minus it becomes plus and you get back this equation. Now if you observe x1 of n is nothing but, see this part if I call x2 of n. What is x2 of n? Nothing but x1 of minus n. Correct? Hence we'll apply time reversal property. Applying time reversal property, we get. What is x2 of n? x2 of n is equal to x1 of minus n has a z transform. x2 of z is equal to, if you replace n by minus n, z gets replaced by z to the power minus 1. You get x1 of z to the power minus 1. That means z to the power minus 1 divided by z to the power minus 2 plus 1. Multiply numerator by z square, denominator by z square, that gives z divided by z square plus 1. In ROC also replace z by z to the power minus 1. So if you take reciprocals, you get mod z less than 1. So now what is x of n? X of n, okay, next what I will do, applying, say what is x of n? X of n is x2 of n multiplied by minus 2 to the power n. Applying multiplication by an exponential and linearity property, we get. Both will apply together. We get. What is x of n? X of n is equal to, correct now? What I said, applying multiplication by exponential property and linear property together. Minus of 2 to the power n into x2 of n has a z transform. X of z is equal to minus of, this minus sign is nothing but this minus sign. When x2 of n gets multiplied by 2 to the power n, z gets replaced by z by 2. So you get z by 2 divided by z by 2 whole square plus 1. In the ROC also, you replace z by 2. ROC is mod of z by 2 less than 1, which implies mod z less than 2. This is the end of the solution. So I applied multiplication by exponential and linearity property together. Because of linearity properties, minus n on the left on the time domain signal is transferred to z domain signal. Because of multiplication by exponential property, z has been replaced by z by a. Z also should be replaced by z by a in the ROC also, where a is 2 in this case. Next problem. Find Z transform of x of n is equal to 2 to the power modulus of n. First let me sketch what is 2 to the, instead of 2 to the power modulus of n, let me take half to the power modulus of n, because we want convergence. And y-axis is x of n. This is an even signal. This is n equals 1, n equals minus 1, n equals 2, minus 2, n equals 3, minus 3. When n is 0, you get 1. When n is plus 1 or minus 1, you get half. Both these are identical, half. When n is minus 2 and plus 2, you get 1 by 2 square. 1 by 2 square means 1 by 4. When n is minus 3 and plus 3 in this expression, we get 1 by 8. There are several samples extending from minus infinity to plus infinity. This is an even signal. For positive time, x of n will be called x1 of n. And what is the expression? Half to the power n into u of n. When n is equal to 0, you get 1. When n is equal to 1, you get half. U of n gives the location. Half to the power n gives the amplitudes of the samples for positive time. For the expression for x of n from minus infinity to minus 1 is x2 of n. x2 of n is equal to half to the power minus n u of minus n minus 1, which is same as 2 to the power n u of minus n minus 1. This I call figure 1. So from the given expression x of n equals half to the power modulus of n, I have written this figure. X of n is equal to x1 of n for positive time, x of n is equal to x2 of n for negative time. From figure 1 we can write x of n is equal to x1 of n plus x2 of n. What is x1 of n? x1 of n is half to the power n into u of n. What is x2 of n? 2 to the power n u of minus n minus 1. Recall a to the power n into u of n has a z transform z divided by z minus a. ROC mod z greater than mod a. Hence x1 of n is equal to half to the power n into u of n has a z transform. x1 of z is equal to z divided by z minus half. ROC is mod z greater than half. Recall minus a to the power n u of minus n minus 1 has a z transform z divided by z minus a. ROC mod z less than mod a. Hence 2 to the power n u of minus n minus 1 has a z transform. x2, this I call it as x2 of n. So what is z transform of x2 of n? x2 of z. What is x2 of z? This is nothing but x2 of n as evident over here. x2 of z is what? Z divided by z minus 2. ROC mod z less than 2. Please note here, this minus sign, linearity property says, if you multiply both sides by, means time domain signal by a minus sign, z domain signal also gets multiplied with minus sign. Therefore here you have to put a minus sign, which you must not forget. So correct. Next, applying linearity property, we get x of n equal to x1 of n plus x2 of n has a z transform. X of z is equal to x1 of z plus x2 of z equal to z divided by z minus half minus z divided by z minus 2. Intersect the two ROCs. In ROC is intersection of mod z greater than half and mod z less than 2. So you get mod z greater than half less than 2. This is the ROC. This is the ROC. So very important point here is if there is no minus sign here in the z domain signal, like here there is no minus sign here, in the z domain signal you have to put the minus sign. This is because of linearity property. Next, properties of ROC. Properties of ROC. Properties of ROC. First property, no poles of x of z, no poles of x of z can lie within the ROC. Within the ROC. Very important. Second one, poles form the boundaries. Poles form the boundaries. Poles form the boundaries of ROC. Third one, for a finite length, positive time sequence, the ROCs are as given below. I'll create a table like this. This column stands for x of n. This column stands for ROC. First one is right-sided sequence, means positive time sequence, right-sided sequence. ROC is mod z greater than 0. Second one, left-sided sequence, means negative time sequence, left-sided sequence. ROC is mod z less than infinity. Third one, bilateral, mod z greater than 0, less than infinity. Right-sided sequence, what I mean is positive time sequence. Left-sided sequence means negative time sequence. This bilateral, which comprises of samples of x of n for both positive values of n as well as for negative values of n. Fourth one, for a right-sided infinite length sequence, the ROC is mod z greater than modulus of P max. Modulus of P max, where P max is the farthest pole from the origin. Farthest pole from the origin. This means all the poles of x of z lie interior to the ROC. Fifth one, for a left-sided infinite length sequence, the ROC is mod z less than magnitude of P min, where P min is the nearest pole, is the farthest, is the nearest pole from the origin. From the origin. P min. This ROC means all the poles lie exterior to it. All the poles lie exterior to it. All the poles lie exterior to it. Sixth property, for a bilateral infinite length sequence, the ROC is mod z greater than P1 less than P2, where P1 and P2 are the poles of x of z. It may be noted that ROC is an annular ring with no poles within it. However, poles lie interior and exterior to the ROC. So what I have written here, for a right-sided infinite length sequence, the ROC is mod z greater than magnitude of P max, where P max is the farthest pole from the origin. This means all the poles of x of z lie interior to the ROC. For a left-sided infinite length sequence, the ROC is mod z less than modulus of P min, where P min is the nearest pole from the origin. This ROC means all the poles lie exterior to it. For a bilateral infinite length sequence, the ROC is mod z between P1 and P2, where P1 and P2 are the poles of x of z. It will be noted that ROC is an annular ring with no poles within it. However, poles lie interior and exterior to the ROC. Seventh one. X of z is analytic. X of z is analytic within the ROC. This means x of z can be differentiated. X of z can be differentiated with respect to z any number of times. As an implication of this, this x of z may be represented by a Lorentz series. If ROC of x of z contains unit circle, then DTFT means discrete time Fourier transform can be obtained from x of z by using the substitution substitution, z replaced by e power j omega. That means x of e power j omega is the dtft, which can be obtained from x of z by replacing z by e power j omega. This is nothing but dtft of x of n. Thank you. With this we conclude this session.